Hello everyone, my name is Florindo Gaspar. I'm from the Polytechnic of Leiria, Portugal. I will present work titled Experimental Study on 3D Printing of Concrete with Overhangs. This work was done by a research team composed by Brun, Florindo Gaspar, Artur, Mateus, João, Vitorino, and Francisco Dias. One of the big advantages of the 3D printing of concrete is the ability for printing complex shapes, and this has been done in various works of various authors and shows us very interesting shapes, very interesting designs. However, this arises also a question, which is what are the limits of the technique, especially when you talk about printing of concrete by an extrusion process. So this work is about studying those limits. And the main goal was to evaluate and optimize concrete printing with overhangs. Our research team has been focused on a variety of case studies, like the one which is shown in the figure, and the question is, what is the limit? So, what is the limit of these overhangs? So, this work was carried out with the objective of study those limits in the printing of overhangs, together with the optimization of the mixture composition in order to get knowledge on this area. For this experimental work, this was the equipment used for printing. It is composed of a robotic arm and extrusion equipment that you can see in the figure. It is an equipment that allows us to print small specimens, which is what we needed in this case. Small specimens to allows us to study a variety of variables that I will tell you after. For this work, a couple of concrete mixes were used and some materials were selected to those mixtures. 17 compositions were prepared with cement type CEM2AL 42.5R, fly ash, rock aggregates of two types, granite and limestone, superplasticizer, hardening accelerator, and polypropylene fibers. The experimental work comprised two phases. The first phase had the objective of getting a mixture optimization in order to be able to extrude and print successfully. This was the first phase, and the specimens, the type of specimens produced in this first phase is as is shown in the left figure, which is a square with walls more or less 2 centimeters wide, and this square has 200 millimeters side. In the second phase, the same type of specimen was used. However, the goal was to study the printing of overhangs, and these overhangs have different slopes, starting from 7 degrees to 17.5 degrees, as shown in the figure, in order to evaluate if the composition can meet the requirements of this specimen, and also higher slopes were tested higher than 17.5 degrees. In the first phase, 5 mixtures were tested according to the table. The objective was to test the influence of the rock aggregate size, binder aggregate ratio, and the amount of superplasticizer. Best results were obtained for limestone aggregate. Granite used on a mixture S2 and S5 gave segregation and bleeding, and also the binder aggregate ratio influenced the results. Good results were obtained for mixture XS3 with 50-50 binder aggregate ratio. S3 was finally the best result on this first phase, and also the increase of superplasticizer from 0.5 to 1% gave better buildability after printing. In the second phase, the mixture S3 was used as a reference, and the optimization of the mixture composition was done together with the study on the printing overhangs. And related to this, water cement ratio, amount of superplasticizer and hardening accelerator, cement fly ash ratio, and fibers were optimized. Better results regarding the first group of tests, which comprises the mixtures D1 to D5, was obtained for mixture D3, which is 36% of water cement ratio, higher water cement ratio, and also higher amount of superplasticizer, more than 1%, gave poor buildability, and hardening accelerator was used as 0.5%. The content in fly ash content did significantly influence the results, and here the best mix was D7, which comprises a cement ratio of cement fly ash ratio of 70-30%, which was used afterwards in the printing tests. Based on the previous best mixture obtained, D7, the influence of fibers was also tested. It was possible, like it's shown in the figure. However, some drawbacks, like the difficulty in the extrusion and also the appearance of the specimens, giving a rough appearance, were the main major drawbacks of these compositions. The results of the printing tests were compared with the flexural, compressive, consistence, and workable life tests, which were tests conducted according to European standards, as is shown in this slide. The lowest strength results obtained are related, of course, with the lower binder aggregate ratio, namely on mixture S1. Also, higher flash content did lead to lower strength results, namely for mixture D9. Consistent results of the spread diameter were between 140 and 175, which showed to be appropriate for the printing results. The best mix was again D7. It was the better for the printing and also the better for the strength results together. Also, the 30 minutes of workable life showed to be suitable for the results obtained. It was the time better to have good extrudability and good printability at the same time. During the printing tests, some failures occurred. and printing was not possible for overhangs with slopes higher than 17.5 degrees. So a 3D finite element model, like is shown in the figure, of the specimens with the overhangs. This model was prepared using the Autodesk robot structural analysis, where the material properties as a simplification were taken as linear elastic. Some results of this modeling are shown in the figures. In the left figure, it's shown the compressive stresses. Maximum compression stress is 1.88 kilopascal, which is not so big, and according to the results from other autos and also from our recent tests, these compression stress should not lead to failures. Regarding tension stresses, they are shown in the right figure, and it can be seen that there are some tensile stresses that are probably the cause from some failures occurred. The main conclusions of this work were the aggregates of rock type limestone were the ones with better results. Also, the best performance was obtained on the mix that is using cement fly ash ratio of 70-30%, 1% of superplasticizer, 0.5% of hardening accelerator, and consistencies between 160 and 175 centimeters with workable life of 30 minutes. 3D printing of specimens was possible with overhangs over till 17.5 degrees, and the most probably cause of the failures occurred was because of the tensile stresses on the upper border of some specimens. Future developments are being done in order to see the possibility of making increased angles in the printing of overhangs. Many thanks for your attention, and please feel free to contact me if you want